right, do the thing. Be careful. If you paid attention to the last two lessons, what is one rotation? What is one revolution? Okay. And for the circle at the bottom, it is the right-hand side that is shaded with a central angle of 150 degrees. Gonna play a deathly silent commander game over there. I'm seeing these two. Okay.
Should we say units? Oh, I'm fine.
See a little bit of scribbling we there.
You stop at B, right?
Yeah.
I watched the video. I just making sure I can get any farther.
Yeah, because 6A and B were just formula plug and chug. It was more about the donut thing. First part. If I break up into quadrants, a circle is already broken into 4 parts, so a rotation broken into 4 pieces or fourths is 90 degrees apiece. That means if I'm talking 3/8 of a rotation, if I know what a circle is, every one of those eighths is 45 degrees or pi over 4 increments. Now, I didn't have to do the whole circle business to do that, but if it helps you wrap your head around things, yay. Right? A negative 3/8 rotation is a negative 45 degrees or negative 135 degrees or a negative 3 pi over 4. If I want all coterminal angles, then I would have to switch over to green. I would add increments of 360, where n is an integer, or I would add increments of 2 pi, where n is an integer. If I want positive and negative coterminal angles, positive ones, nice and easy. Just go the other way. 3/8 of a rotation means I got 5/8 left. If every one of those eighths is a quarter pi, then this is going to be 5/4 pi, or 5 pi over 4. Or if I want a negative angle, this is already my angle, so I got to go all the way around the block and try it again. It'd be a negative 3/4 pi plus another 8/4 pi, or negative 11 pi over 4. Arc length. Arc length is from here to here. And arc length is nice and easy. I could do 2 pi r times x out of 360, or radians times the radius, which in this case is going to be 150 degrees in radians is 5 pi over 6 by 12. Right? 5, 6, 6, 6, 6 cancel, just 10 pi. If I instead wanted U. Area. Area of a sector is 1/2 radians times radius squared. So it's 1/2, be careful, unshaded sector. If 5 pi over 6 is shaded, then 7 pi over 6 is unshaded. And 6 and 12, 6 and 2 is 12, 144, 12, 12, 7, 84. There should be 5 things. Need to find your plug and chug, need to find your plug and chug, need to find your Angle itself, your coterminal angles formula setup, and then your positive and negative coterminal angles. Okay? A lot of little stuff. It's just, as we're discovering, there's a lot of stuff that we didn't pick up. Stuff we either didn't do in geometry or missed out in Algebra 2. We were doing great all the way up through the middle of chapter 2, and then all of a sudden we started just kind of hitting a slog. Just to go through, we got 2 seniors in here. Boy, is that going to mess with things. Originally, what would have happened for our seniors is we would have gotten all the way through chapter 6. You would do 10 on the side on your own. Like I give it to you at the beginning of chapter 4. I just forgot because last week was a disaster. And then you take your final when you're ready. But now I don't know how I'm going to wiggle that because we got bogged down. Chapter 3 took us about 4 days longer than it should have, nearly double the time. And after this morning, I'm kind of worried about chapter 4 because that's normally a 3-week adventure. So I don't know. I genuinely don't know. Think a little bit between now and then as to what you're going to do. Everyone else, we finish off chapter 4. We go back and do 7 before 6 because 7 is absolutely critical to moving on to trig. Then I'm going to give you as much of 6 and 10 as I can. Kind of triaging out stuff that maybe isn't as relevant, like inverses and Kramer's rule for matrices. Might give you the short version of sequences and series, since most of you have had that before. In Algebra 2, I think the new curriculum runs through the formulas for those.
Or where, you did the pyramid?
No, that was Pascal's triangle. This would be, given a series, find the sum of the series from the 9th term to the 39th term. And you plug stuff into formulas. It's actually the easiest chapter of the entire course. But I don't know that we're going to have time for it. The review is going to be just like first semester. Oh, wait, this is a 1 semester class. The review is going to be on your own. I'm just going to hand you the review. Get it? You get to use the review and whatever you can fit on it for your final. And it's going to look the same type, same spot. Solutions are online, but you got to do that on your own. Because every time that I've tried to do a review in class, what happens is kids just check out for a few days, not pay attention as we're going through stuff, and then they all cram the night or two before anyway. So I'm just going to leave it to you. We finalized that school board meeting last week. You are going through the 26th now. That bumps everything up. So you will have one more maroon day right here. Finals. Maroon 1, 2, 3. Go away. Open first block. 1, lunge, 2. Go away. And then white 3, white 4. Let you know in here, I give you an option if you want to do a final on both days, which is typically what we do for the math classes. It's a 2-day final because you're in here every day. It'd be 40 questions split 20 each day. Or I give you the option of 1-day final, 20 questions only. I pick the most important ones. No class has chosen a 2-day final since I started giving that option. See, you got choices, right? Because it's multiple choice, just like an ACT for those who have taken it. Of those 5 questions, or of those 5 options for every question, this one might be right. This is I squared like a freshman, ran it all the way to the end zone. This is I missed a negative and ran it all the way to the end zone. This is I cubed instead of squared and ran to the end zone. This is I wrote it as a decimal approximation instead of a radical. Like the most common errors that kids make are the other answers. So it's very hard to get an A, but it's also very hard to fail because it's 1 point for reasonable work relating to the problem, 2 for the correct answer.
So there's no excuse not to get half of it.
You could get half the test wrong, you will still have a 67.
67. Why not 50%?
Because you had your work shown for all of them. That's a third of the test. Half of the problem's wrong. That's another third of the test. 2/3, 67%. Reasonable work related to the problem. 2 points for right or wrong on the answer. So very, very hard to get a fail. But you can only get 2 wrong before you lose your A. But if I go up to 40 questions, now you got a little bit more wiggle room. So it depends.
Which one did you recommend?
I mean, I'm going to recommend the 1 day because it's less for me to grade.
Use your head.
I use my head. Okay.
So
Then you have more time to study as well.
now I'm also letting you know that you get a choice. You all will be in here, you're scheduled to be in here these 2 blocks. I don't care when you take your test, so long as you schedule it ahead of time with me. You can take it there, 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 or there. I don't care. And that's my, oh wait, no. Wait, 2. There we go. Forgot when my own prep was. There we go. Nope, that's a class. There we go. I don't care when you take it. If you vote for a single day final, then I ain't looking for you. Don't bother showing up. Okay? So that's just kind of how the rest of the year is going to go. Yes, there is testing on Wednesday this week. Most of you will be in there. The others will do things. I don't know, I'm going to be grading. Speaking of, the sleep deprivation continues. I am not going to lose more sleep and get less done at home during very, very hectic time in order to get all of the packets in. If you know how weighted grades work, it's just a percentage. Your percentage on your daily work is going to be the same percentage on your daily work, whether there's 5 things in there or 25 things in there. So assuming that you have been doing the same amount of your daily work as you normally do, which for most of you is everything, that bucket of a weighted grade will not change, whether I put those in or not. So I'm just going to get your tests in. I'm going to post midterm, because midterm is useless anyway, other than eligibility or Spartan time. Eligibility or Spartan time change because of that, then I will directly contact your Spartan time teacher and administrator. Okay? But I'm not going to put the packets in until Wednesday when everyone else is gone doing testing. I'm going to be grading notebooks and packets. Okay? So, that's where we stand on all of that. The homework, the only questions that I got were basic stuff, just making sure that we did things right. We will attempt to do 4-3, and this time, let's hope that we understand basic substitution and coordinates. So, let's start with all the way back to middle school. When you first start doing coordinates, you understand that x is lateral movement and y is vertical movement, correct? We are now going to take all the circle stuff that we did and we're going to start throwing it on a coordinate grid. This is how we transfer ourselves from basic geometry into trigonometry. A coordinate will exist out here. The distance from the center to that coordinate is going to be the radius. Because it doesn't matter where it is, it's always going to be the same distance, right? The x and the y part of it is going to change based on location. And if it changes based on location, I need some standard way to write these as my trig functions. So our rule is that we are always going to form our triangle with the x-axis. Always with the x-axis. Always with the corner pointing in at the origin. Okay? You do not form your triangle with the y-axis unless you are doing an application like physics, like a word problem when you're dealing with your cardinal directions. If they say it's like 10 degrees east of north, now I would have to go off of the north-south line because they specifically said so. For everything we're doing, we're always going to go with the x-axis. Okay? Now, if I do that, the angle itself is theta. This would be about, what would you say that angle is? All the way from initial starting position all the way around down to quadrant 3. Okay? Probably one of our special angles, though. 240, right? Because it's not halfway through, so it's not at 225. It's a little more, probably 240 because we do those 30, 45, and 60 degree increments. If the entire angle is 240, I'm going to call this theta prime, and we're going to start calling those reference angles. The reference angles, we're going to get to these later. It's like the last thing that we do. Well, it was the last thing we did this morning. We're probably going to get further. Reference angles are always going to be positive. They're always going to be formed with x-axis. And they're always going to be acute. Correct. Because it's inside that triangle. If I'm forming a triangle with the x-axis and I'm just looking inside the angle or inside the figure, we don't regularly have like a pentagon and say that this is negative 120 degrees. Positives and negatives just determine direction. And that was something that we kind of had trouble with first hour, is that coordinate xy is down in quadrant 3 right now. What are my coordinates in quadrant 3 like in terms of their signs? So we're so used to the sides of a triangle can't be negative. That was pounded into our head in middle school. And now I'm about to tell you that this can be a -1 and a negative square root of 3 and a positive 2.
Well, that kind of like breaks logic.
But what does the negative mean? It's just direction. Okay? The side length is 1. The side length is square root of 3. But because they're -1 and negative square root of 3, they're telling me which direction I'm going. Just like positive angles go this way. Wait, other way. Negative angles go this way and positive angles go that way. Right? So the negative only means direction. Okay? Now, take a look at this triangle again. Isn't this right here from theta prime? Oh, green, get back here. Isn't this the adjacent and the opposite and the hypotenuse? And I went this way. I went this way. Left and right is your x. Left and right is always going to be adjacent. I went this far down. Up and down is always opposite. If I always form it with that axis, opposite will always be the y part of the coordinate. Which is why we get, if you look next to this, they're called the XYR coordinate shortcuts. X, Y with a radius is going to be the same as, oh, get back here, adjacent, opposite, hypotenuse. This is going to allow me to translate just basic right triangle trig stuff into a location. Now I can take what I know about triangles and start to use it in terms of direction, in terms of magnitude, if you remember hearing about vectors before. Okay. Just this idea, beginning of 4-3.
R is radius.
Yes. And if it helps you, these can be negative. In fact, we should probably write that up here. These can be negative to show direction. This is distance from origin. So because it's distance, it's always positive. Okay. We were just in that first text box of 4-3.
Oh, okay.
We're talking about the how and the why before we start doing things.
That's why the radius is lower than this weekend.
The radius is the
I
hypotenuse.
haven't even touched my backpack this weekend from the days I missed, so am I gonna be like super duper
Yep.
off? So
I'm surprised you didn't think I wouldn't have.
I just barely got back from Arkansas. You'll be fine.
Throw in some headphones, start doing the video from Friday now.
What do you think I should do?
Yeah?
Okay.
There's no point trying to do this right now if you didn't do the Friday stuff.
Okay. I didn't do Thursday.
Or dude.
Am I way behind? No.
We're kind of talking about the entire definition of what we're doing today
Okay.
on the last 2 days. So, yeah. Yeah, we might want to get that taken care of.
Yeah.
See, that's why all of these coordinate shortcuts are written the way they are. Y is always going to be the opposite side across from my angle. This is opposite and hypotenuse. This is adjacent and hypotenuse. This is opposite and adjacent, and notice that they say x can't be 0 because you can't divide by 0. And they tell me that the radius I find with Pythagorean theorem. Okay? Now technically, when I do, I solve. And when I solve, I do square root, which means I would have a plus or a minus. But we're not going to put a negative on the radius because it's the distance from the origin. The other two are allowed to be negative because they're denoting direction. But the radius will always be positive because of that. Also, what happens when I square a negative? Right? So they're always going to end up with positive values in there anyway. Okay, so we start with a lot of front loading, a lot of talking. I'll come back to this after doing the first part. Okay. So they give you a coordinate. They say it's on the terminal side of standard angle. Go find all of its trig ratios. So first up is, you tell me in what, yes, SOHCAHTOA and, what did you call it? Sakatol? Cosecant, secant, cotangent, instead of SOHCAHTOA. I don't even know what, it was just like some, okay? What quadrant is the coordinate 8, -6 in? 4, right? Left, right, up, down. So the coordinate itself is hanging out down here. If I want to find the trig ratios of it, I translate that knowledge into triangle. Make triangle with x-axis. Like it is. Now can you label the sides of it using that coordinate information? X is left, right. So, Y is the up, down. -6. Remember, the negative tells me the direction. And then,
64.
we do say the negative. Yeah. This is theta itself, but I'm going to be working with theta prime inside. Okay? Then I got to go find the hypotenuse. Hypotenuse is found with Pythagorean theorem. My radius is the square root of 8 squared plus -6 squared, or, does anyone recognize their triple? 10. Okay. Now, notice I just got R was 10. I could now, from this angle, talk about opposite, adjacent, and hypotenuse. What I'm telling you is that you don't need any of this, because now we have the XYR shortcuts.
Or you just look at it and go,
No, I'm saying I don't even need any of this, none of it, because here's an X, here's a Y, go find R.
so X will always be adjacent, Y will.
The sine of theta is opposite over hypotenuse, which is going to be R. Cosine of theta is going to be adjacent over hypotenuse. Tangent of theta is going to be opposite over adjacent. Cosecant reciprocal is hypotenuse over opposite. Secant is going to be hypotenuse over adjacent. Cotangent is going to be adjacent over opposite. Those are the XYR shortcuts on the front page. What I'm telling you is you can just make this not exist. You can just use the shortcuts and plug and chug those 3 numbers. Or you can draw the triangle to wrap your head around it because the formula part doesn't work for you. I'm telling you that you can do both. You can do algorithmic or you can do visual. Cool.
Yeah, I'm good, but the trigonomic functions are just the sine, cosine, tangent.
and they're reciprocal buddies. Yep.
Okay.
So, plug and jug. I can say y over r, reduce it. X over r, reduce it. Y over x, reduce it. And then flippity flop the whole works. Negative 5/3, 5/4, and negative 4/3. Be careful with your negative. We normally don't write it on denominator. It's considered improper. Just write it out front. Put it in front of the entire fraction or up top if you want. I would recommend in front of the entire fraction because we're going to start seeing where that negative could have been. Either one, depending on what quadrant I'm in. Okay?
My calculator doesn't care. It's fine.
It does. It's just a coincidence that they're the same right now. Just wait for it. It's coming. Okay? Just wait for it. It's coming. This is how, have you ever just poked buttons on here and sometimes you end up with the cosine of whatever and it tells you negative? Or the sine of whatever and it tells you negative? This is why. Because sine, cosine, and tangent can be positive or negative depending what quadrant the angle is in. And the negatives just tell me about direction. Okay? So, whether you want to redraw the entire thing or use the shortcuts, I don't care. Both. First one's going to come out nice. Second one's going to involve a radical. Go! And in the interest of transparency, I got very frustrated with first hour because I've never had an issue with this in 15 years. Yeah. I shouldn't. I got frustrated because I'm tired and I was completely caught off guard by someone having an issue with this.
Wait. So keep in mind I'm on Wednesday's knowledge
Yeah.
because I was kind of a train wreck weekend. But so when you got to find all these remaining values,
Yeah.
you use like the
You got to find the missing side first.
and you use the what's it called? The value where it's like square root of 2 or whatever.
Only if it's a
The
special right
ratios.
triangle. How do you find it otherwise?
It equals 9. I don't know how I forgot. Just like totally spaced it because I remember it's like super.
Go back
easy.
to middle school.
Oh, Pythagorean theorem.
There you go.
Oh, that's great. Sorry.
Still looking at axis.
Kill him.
I'm going to.
Do it.
I'm trying. My turn.
Wait, can you have a negative square root of 5?
Spanish class, I was taking my test, and people were getting like super frustrated.
Yes, test in Spanish. You have one tomorrow next. Maroon or a white day?
It's a maroon day.
Oh, I thought it was a white day. Oh, that sucks.
How did you get to period 3 if you were
I
right
totally thought it was a white day. I would have
But
gone.
when you were maroon day classes, you were in your
Okay.
maroon day classes all day.
My maroon and white 3 is the same class.
And he just showed up at school at 12:45.
To which I will applaud you for showing up today. Good job, Max. Oh, bagging on Max when he just wants to come further his education. Okay, are we okay with the positioning of them? Position cool? All right. No, I'm going to show the visual part for those that need the visual part.
All I did was just.
What I'm saying is, if I see a 4 and a 3, I can just do Pythagorean with those two numbers and say R is 5. If I see a -2 and a -1, I can say R is root of 5 by doing Pythagorean. Okay? Now, if I need to see that on here with Pythagorean triple or with doing Pythagorean formula, whether I need the visual stuff or I just look at, hey, look, I've got X, Y, R. I've got X, Y, R. I can either shove those three numbers into my shortcuts or draw the triangle and I'm good to go. So we're going to have sine, cosine, tangent, cosecant, secant, and cotangent. Some of the yelling might have also been those three stooges in the back because I am this close to having a seating chart in PreCalc for the first time in like 5 years. No, just them. They're the goofs. That's why they're on the board. That's legit what I would do. Okay, so 1A. By the way, amazing segment and podcast on NPR. Sine of theta is going to be 3/5, 4/5, 3/4, flippy floppy. 5/3, 5/4, 4/3. Are we okay with that one? Because integers, yay, easy. But contestant 2. Careful. Make sure you're rationalizing all of these. Are we getting the rationalized versions of them? Sines too. Which ones are positive and negative? Okay. And then flippity flop those. Should have a negative root of 5, a negative root of 5 over 2, and then just a plain old 2. Okay. We cool with that? Like, legitimately, no fuzziness.
I mean, it's just what we did like on Wednesday.
I think
Okay.
it's easier than what we did on Wednesday.
All right. Awesome. We're already 15 minutes ahead of the first hour. See, what happens is in geometry, everything is hypervisual. In algebra, everything is abstract or algorithmic. You all know this because you took both and you probably have a preference for one or the other. Kids seem to really like algebra and hate geometry, or really hate algebra but geometry was awesome. And when you get into trig, you put them together. So everyone that has a preference to one or the other is going to feel a little squirrely. Everyone is going to have a different part of it that they don't really agree with. Okay? Unless they just didn't care. Okay. Oop. Okay. Oh, now we got to go back to the beginning and talk about one of the most entertaining words in this section, quadrantal angles. Quadrantal. Sounds like a dentist. So, like, just listen to what it says. Quadrant angles. Quadrantal angles. They're the angles at the quadrants, which we should know are, well, I was gonna have you do them, but they're right there in front of us. 0, 90, 180, 270, 360 versus increments of pi over 2. Pi, 1/2 pi, pi, 0, 1/2 pi, pi. 3 pi over 2 for some reason trips kids up, and then 2 pi. At the quadrantal angles, you've got a couple ways to think of this. Is that a question or are you going to kill it? Oh, I thought there was like a fly in front of you. You're like, land, I dare you. Okay. How we work with the quadrantal angles really depends on whether you are the visual type or the coordinate type. If you're the coordinate type, it doesn't matter how big this radius is, right? The radius could be 1, the radius could be 31. It don't matter. When it lands on the quadrants, it's whatever the radius is, right? So if the radius was 1, this would be 1, 0. If the radius was 31, it would be 31, 0, right? So that's why we like to just say r. Because whatever the radius is, it's going to be that. Now, this is an x, a y, and the radius, r is just freaking r. Okay? This is an x, this is a y, r is just freaking r. I think at one point I finally just snapped and started writing r is freaking r on the board. That's it. The radius is the radius. It might also replace either the x or the y portion of the coordinates when it's on the quadrant lines. Okay? So where it's going to get weird is when I try to do my trig ratios with these when there might be a 0 involved. So like right now, if I'm at 0 degrees and I said sine, right now, what's the y coordinate? Because, right, it's going to be y over r. No. Y over r is 0 over r, right? Y part of the coordinate. So the sine of 0 is going to be 0. The other way to think of this is just a visualization, is that think of it like a triangle in which the radius goes this far, the radius goes this far, but because this is 0 degrees, the opposite is 0. Okay? This is just a visualization. There is no triangle. It is literally just two sticks laying on top of each other. So if there's just two sticks laying on top of each other, there is no opposite. So if I said the sine of theta was opposite over hypotenuse, when I'm at 0, I'm going to say there's nothing over a number. so it's going to be 0. The quadrantal angles are the ones that get weird because those are going to have either, volume down, they're either going to have 0, 1, -1, or undefined. Okay, so the quadrantal angles get weird. What if I was at this guy and I asked for the tangent? The tangent of 90 degrees, the tangent of pi over 2. This is x, this is y, r is freaking r. Well, tangent, isn't that y over x?
0 over
Y over x.
R.
R over 0. Thou shalt not divide by 0, undefined. The tangent of 90 is undefined. If you want to think of it in terms of a triangle, think of a ridiculously skinny triangle. If this was like 89.999 degrees, these two would be really close to each other, right? It'd be like 1999 and 1998. Like they'd be so close to each other. Well, what happens when it's boop, up to 90? Tomorrow. You don't have to take it tomorrow if you don't want to. So those two would be the same, and there wouldn't be any adjacent because it didn't move left or right.
Hopefully you made a lot of money.
So the tangent would be opposite over adjacent. I would end up with number over there is none. So take number divided by 0 and undefined. Okay? So the quadrantal angles, you can either use the XYR shortcuts, or you can go back to good old opposite adjacent hypotenuse, understanding that it's not really a triangle, it's just a pair of sticks next to each other. Which means opposite or adjacent won't exist. Okay. So, sine of -180. First of all, where am I? Northeast, south, or west? So where am I?
South.
We go this way, so.
What you asking? East, south? Because you're going down. East, south.
East to west.
Oh,
You're at west, you're south.
Whoop!
I just thought down. I just thought down.
This side to that.
Yeah.
Like, I know where it is.
Where is it? Okay, so if I wrote that as a coordinate, square both parts. So this is going to be at -R0, right? Negative x coordinate, no up or down for y coordinate. And if I were to label those, it would be, this is x, this is y, r is freaking r. Because the distance from here to here is r. Radius is radius. 5 is 5. Mr. Incredible yelling, math is math. Okay? So, I can use my XYR shortcuts that says this is y over r, which in this case is who over what? 0 over r, which is 0. Or I could draw my non-existent skinny little triangle that says this is r, this is -r, this is 0. because there is really no opposite if it doesn't go up or down. And then go find the sine of this angle. Sine of this angle is going to be opposite over hypotenuse. Still 0. Okay? So either triangle version or coordinate version. 3 pi over 2, where are we at?
You're at
South. Okay, south. Okay, 3 pi over 2 is going to go like this. So what's the coordinate if my radius is r units?
0 R.
Close.
X.
0, negative r. Coordinates show direction. Okay, so if I'm right there, I have x is 0, y is negative r is freaking r. Because the distance from the origin to this point is r units. Tangent is who over what? No. I'm going to say that's cotangent. We were close. Okay, so this is going to be y over x. So tangent of 3 pi over 2 is going to be y over x is no.
also the way you determine if it's like a y, the r radius is if it's on the y-axis or x-axis.
Because opposite is always y, adjacent is always x, hypotenuse is always r. And if we need to make sure we understand it, hypotenuse is always positive. Okay? Well, you got the 3 stooges in the back who just don't shut up, and that complicates things. And then apparently we're just struggling with like basic concepts. Like we're finding holes in the knowledge. Also, it's been 3 hours since that class. By the time I get to you, I've had time to cool down and think about how I want to say things differently.
But we can start over different stuff.
Yeah,
We're just better, Jason.
usually it's just staying on task and not getting derailed.
That's nice.
Okay, negative 90, where are we at?
South.
Oh, hey, look, same spot. It's just I went this way instead. My coordinate is still 0, negative r. I still have x is 0, y is negative r is freaking r. So, cotangent of an angle is now x over y.
That is
What?
the coordinate.
0 r. Or negative r, sorry. It's itty bitty. I mean, it is getting warmer out. Maybe it's just wearing less. Anyway, x is going to be 0. Y is negative r. 0 divided by anything is still 0. Okay? Every one of the quadrantal angles is going to have 1, negative 1, 0, or undefined. That's it.
So are the tangent either 0 is not real?
1, negative 1, 0, undefined. That's the only possibility is at quadrantal angles. Go. We did?
Negative 90.
Oh. Fine then.
Or we could have.
Oh wait, we won quadrantal angles. Sorry. Wait. Did I zoom in the wrong one?
Yeah, we didn't do secant.
Do the other one.
Secant of
Do the other one.
that one.
Yeah. Do the other three that I haven't done because I zoomed in the wrong one. Walmart doesn't even have B8 staples.
I bet you can order.
Wait.
Yeah.
4 pi, you go around twice. So it ends up at 0. Still. What? Do I have to draw this thing around twice?
Okay.
Oh, here we go.
They're going to make such a racket about this. What? I didn't do anything.
Sir,
What did you get?
what did you give him? It's gonna matter. What the heck is 4 pi? Like, I know it's a radian, but like, where is it? Cause it's not on.
How much is 2 pi?
2 pi is this.
So it's 4 pi.
So it's double that for no reason?
Whee! Sometimes it's just fun to spin
What do
around.
we do here for this?
Solve.
Solve what?
Solve for x.
Where's the oh, that x.
That was the x.
Wow. Oh man.
It's a 30, 60, 90
forgot
triangle.
I forgot a lot of stuff.
It's a 30, 60, 90 triangle, right?
Okay.
So if that's, this is in what spot?
Oh, I forgot so much stuff. I know that's the square root of 3 spot.
Okay, so you say,
1, 2.
no, this is 2. That's square root of 3.
Oh.
Remember a bigger one?
Okay.
So I'd say this, stupid iPhones. I'd say this over square root of 3, because it's in the square root of 3 spot, equals that over 2, because it's in the 2 spot.
And then you just cross multiply.
Choop, choop. Yep.
And then this one, I think I'm gonna have to run through it in study hall.
That was the draw out the
That-
two
yeah,
triangles.
That was the big thing
Yep.
that I was totally lost on.
So I did that one right or wrong?
No, secant R0. It should be 1.
Why? Oh. Yeah.
On C?
What was this one? Secant 4 pi? Okay.
You get coordinates 0, R.
R0. Now, the difference is he doesn't know the lines of play in there as to which enchantments to go get.
It's still bad. It doesn't matter what he gets. It's still
It's
bad.
Voltron.
It's you building Voltron, but you get a free card every turn. It's good.
So it's all over.
The biggest thing you want to do on the, also, I have protection from every other color besides white. And they're 1 drop, so you can tutor them immediately. Do we have the location correct? Okay. Then we're at 0, negative R. We're at 0, R. We're at R0. And X is 0, Y is negative R, R is freaking R. X is 0, Y is positive R is freaking R. X is R, Y is 0, R is freaking R. And then, since cosine is X over R, I would put X over R 0. Ask. Legitimate. We're like 15 minutes ahead of the other class.
If I was up there, I'd be asking.
Okay.
What's the question?
Cosecant is R over Y. R is freaking R. Y is R. R over R is 1.
Do you have to put the pi over 2 in that part? Do you say like equals pi over 2?
No, I'm finding a value. I'm not solving equations. No equal sign. It's asking a question of a value. It'd be like me asking, what is your age? Okay. Secant is R over X, or hypotenuse over adjacent. Well, when the hypotenuse and the adjacent are the exact same thing, yes. The abstract piece of it is that and when you try to go concrete with it, well, what happens when I try to say that this is a triangle of 0 degrees with R, and this is 0? And then was met with, but it's not a triangle. I know. But it's not a triangle. How can you even have that? I know. Because you're using an abstract representation or a concrete representation of an abstract idea. It'd be like if you tried to draw 4-dimensional space. 4-dimensional space is your 3-dimensional sphere of influence along a timeline. Not yet. So, reference angles. I talked about these at the beginning. The reference angle is always, remember the 3 things? It is always formed with x-axis, acute, and positive. In order to do that, down at the bottom here, yes. So if I'm in quadrant 1, it is what it is, right? 45 is 45. But 135 degrees would have a reference angle formed with the x-axis. So its reference angle would be 45, even though the angle itself was 135. Okay? The positive acute angle formed with x-axis. Yes. So like this one, say this is itself 210 degrees. It's 30 degrees past the x-axis. So my reference angle is 30. If this is 300 degrees, then this angle is 60 degrees off of the x-axis. Nerds. We okay with that? Just, it's always positive. And what we are going to work with primarily in here is 30, 45, 60. Technically also 0 and 90, but it's everything in that one 90-degree arc. Okay? Now, there's some stuff up here about whether they're positive or negative, but that's going to have to wait for Thursday. It's how we build the unit circle, whether things are positive and negative, like the big aha moment. Notice there's a giant box in front of it now. I should probably turn it the other way though. My reference angles. Ah,
Do you do that on
crap.
purpose?
Yeah, I need to turn it though so it covers the whole thing. Oh no! So if I'm at 300 degrees, what quadrant am I in? So this is the angle itself. No. Nope, not you. So if the angle itself is 300, my question for a reference angle and a reference triangle, this is going to be theta, and then we talk about its cousin, theta prime, which is 60. Because altogether they will make either 360 or 180, x-axis. If I'm at negative 2 pi over 3, remember that pi is the calzone, not the entire object, not the entire circle. Yes. So if this is pi, or in this case negative pi, here's a third of the way, here's a third of the way. If you're like me, the axis itself in the middle of that kind of trips you up. So I'm 1/3 of the way, I'm 2/3 of the way. My angle itself is here. This is just sloppy now, I don't like it. So if this is negative 2 pi over 3, I connect it to the x-axis, and I'll say that my evil cousin over here, theta prime, my reference angle, how much further do I have to go to the x-axis? Pi over 3. Yeah. Those are reference angles. We'll tell you when you're older. And by older, I mean Thursday. Literally the second half of section 4.3. The second half of section 4.3 is when I first realized that I happy flap. Like, I get really, really excited about it and the connections between them. It's so good. It's so good. If you've ever had the intellectual realization of when everything starts to fall together, and it just... Sketch all of those, tell me the reference angles.
Sorry, I'm sure it's
Days
annoying
remaining.
that you already taught me all this, but and then I just like, I don't know, it was a long drive. So, anyway, so I understand this model. It's like, I was having a hard time at the beginning. I thought the guy was up there for some reason and stuff like that, but then I kind of figured out. This is the building, the billboard's right there. The billboard's 50 feet tall, and you're trying to find how this length, basically.
So you have two triangles.
Yeah. That one would be 44.76.
The bigger one, yep.
And then that one would be 40.18.
And this would be x, the height of the building. This would be x plus 50.
Okay. Oh,
I'm going to need these as placeholders.
by one. Oh, that's y. Okay.
I'll write out
Oh,
my
I
angle.
remember.
I'll write out my angle. Tangent of this guy is, tangent of that guy is, and then substitute.
Wait, what do you mean tangent of?
Tangent
Oh,
of
okay.
44 and change is going to be x plus 50 over y.
And then you have to isolate y, right? Okay. you ice? Oh, you just cross multiply?
Mm-hmm.
Or just like,
Swap your extremes.
Yeah.
Yay or nay?
those are your,
Why did you say 2 pi? I mean, I agree on.
I thought it was 3 pi over 4.
Can you explain?
Without the coordinate axes on there, it can be kind of tough to see your figure. But if I then do this,
So all of these are
does that help? That 5 pi over 4, here's 4 pi over 4, 1 more is 5 pi over 4. Negative 240, well, here's 180. 180, oh, I wrote it in radians, sorry. Keep going. What do you want, 60 instead? Sorry.
You isolate y1 and then isolate x so that you can.
Once you replace y,
X into the other one.
then you're going to have to solve for x. Yep.
And you do that when it's like tangent of 40.18 equals x over y. That's where you find x equals y times, and then you solve for.
Plug in the y stuff. Y is this junk with x. Yeah.
For 3C, so you just have to subtract because it was bigger
Yep.
than 360. Okay.
And that's where you can have reference angles for things that are way bigger. What if I said, what is the reference angle for 780? Well, here's 360.
720.
Here's 720.
Be
Well, don't you have to get
be 30.
Well, wouldn't it be 60?
60.
Oh,
I'd take away a full revolution. I'd take away another full revolution. Okay.
so it's how much you have to take away.
Well, you always have to form the angle with the x-axis. And since the normal angles that we deal with are 0 to 360, if my angle is way too big, I got to subtract it down to its coterminal angle that's between 0 and 360.
How ahead are we right now?
That's where I ended, and I didn't talk at all about finals or schedules with them.
That's if it's solid, like.
Yeah. Yeah.
It was a little.
Oh, there's also no assignment.